We should see. It's always running a course like this is always interesting, right? Because the experts always get knocked down a little bit when they realise they're not quite as expert as they thought. But we'll see. Right. When we did the questionnaire last year, an S-Pro was told through a picture, just to remind us about what this module was all about. And this module was all about reigning on your social life. Okay? Because you've got so much coursework, you're not going to have a social life. So just in case you want to change your mind, maybe it's not the module you're looking for. Okay. So,
那个女生给你发了是吧？行。西方草原选那个，西方草原选那个，在那。
Okay, so what I want to do now is talk a little bit about JavaScript. So we know in the room there's a few people who have at least a little bit of experience with it. How many people in the room have got experience with Java? Good. Look. Java and JavaScript. Same thing? No. Very much not. Other than the name. So they're very different languages. We're going to see why. And the best way to tell you about why those two things have got names that are similar and they're very different is to talk through the history. So I can give you a very short history of how JavaScript came about. So in order to do that, we've got to set C. And we've got to wind back time. And we're going to look at computing back initially in around the late 80s, early 90s. With all of what computers look like. So Tim Berners-Lee's Nextbox, 1988, he was developing the World Wide Web. Literally, he was developing an application called World Wide Web that ran on his Nextbox, and it was the forerunner of the web that we know today. That piece of software was completed in December 1990. It was released to the world. It was the first web server running essentially. That was written in a language called Objective-C. Has anyone heard of Objective-C? Okay, a few hands. Anyone use it? I don't know for them. Okay. So if you've got an Apple product, an iPhone, and Mac, most of the software is written in this language called Objective-C. Very old language. Roots back to the early 80s. And it's still used today. Wow. Well, the internet wouldn't be the internet without having computers that were connected together. And back then, we didn't have broadband. We had things like modems. We had things like acoustic couplers. So things that you'd actually take your telephone handset, you plug it on top of this device which made funny sounds. And for some of you, this might bring back memories. These modems, these devices use telephone lines, standard copper telephone lines to set up communication links between each other. The sounds that you're hearing now are the sounds of the modems communicating. This is just the handshake. But the entire communication system was done on the basis of audio sent over a telephone line. It was very slow. So if we look back at the acoustic coupler, 300 baud, 300 bits per second. That's really slow. Things did move on, so by about 94, we got up to 28 kilobits per second. But if you consider a modern broadband, so broadband at home for me today, I get about 25 megabits per second. Orders of magnitude faster. So things were really, really slow back then. So any data that you transfer, you really want to be careful about not sending too much, because it would just be different. Wind on a little bit to the early 90s. This is what the computing technology looks like. You've got things like, so a compact Rosario 660. So this is basically your bulk standard IBM PC with a 486 GX2 processor running at a massive 66 megahertz. Okay. And consider if you've got my laptop with a 3.2 gigahertz processor in it. Again, orders of magnitude faster with today's technology. You've got other things. You've got the Mac Classic. Apple was still, was making big computers back then, and the all-in-one thing. Apple wasn't making very much money. It was a really, really interesting time. Steve Jobs had been booted out as CEO of Apple. They actually got off to form Next Computing, that made the Xbox Tim Berners-Lee was using. And a guy called John Scully was at Apple. He mostly is known for selling Pepsi. Apple was in absolute dire financial straits. So what did they decide to do? Well, they decided to license the design of the Mac to the clone manufacturers. So other manufacturers were selling Mac clones, and that was financially even a bit more damage than imaginable to Apple. So that time in computing history, it's really a lot of things happening. Wind forward a little bit more. March 1995, Netscape Navigator 1.1. So the 1.1 release of the first major web browser. So it wasn't the first web browser. Netscape was perhaps the first major company that was selling web browsers or making web browsers. Slightly before Internet Explorer. So there was a big battle between Netscape and Internet Explorer that started sort of after this period in time. So let's set the date in April 1995. There was a guy called Brandon Ike, and he's hired by Netscape. So for some of a dream job, he's working at a big, essentially a big internet startup, 1995, before the big boom, but things are looking pretty rosy for the internet companies. Brandon came into Netscape, got on the job, meets his boss. His boss says, welcome. We want you to start working here by writing us a language that we can run, we can interpret in a web browser. The boss set a deadline, 10 days. 10 days to give us a working prototype of a language that runs in a web browser. And of course, it's a very technically knowledgeable boss. So he said, let's go and speak to the marketing people and find out what they want us to put in this language that's going to run in the web browser. Let the marketing people come up with the specifications. So off they go and see the marketing person. So the marketing guys, they want a language that makes it easy for people to, for authors of web pages, to be able to animate their web pages and make them interactive. And at the time, Sun Microsystems had just released this language called Java. And that was a really, really hot thing. It was everywhere in the press. Java was going to be the thing that takes over the world of computing. So the Netscape marketing guy, he had a really good idea. He said, well, Java's like a really, really hot thing. We should call the product that we're making JavaScript, because it sounds a little bit like Java, and we can make the most of the existing hype around this Java thing. So that's why it's called JavaScript. He also said, let's make it look a little bit like Java. So let's take the syntax and let's use that. But we want to be careful. We don't want to copy it too much, because then we get sued. So we need to do kind of this little Java language to Java. So that's the first day at work. Brandon then goes back to his cubicle at the cubicle farm, sits down, gets coding. Got 10 days to write language from scratch. I think the first thing you think of is 10 days. Clearly going to be a bit of a hack, because to write a programming language in 10 days is a bit of an ask. He did it though. 10 days later, in a presentation to the marketing guys and his bosses, he presents his language. And I've said here, it's a JavaScript case study in hacking together a Frankenstein language. And why is that? Well, it's got lots of interesting features. So the programming environment, the language runs within a web browser. Back then it was a purely interpreted language. It wasn't compiled, it was just purely interpreted, and essentially run line by line. In terms of programming styles, so it supported all three of the major programming styles. So imperative programming, like languages like C, object-oriented programming, like C++ and Java, functional styles like Scheme and Haskell, and it mixed features from all of these languages together to put them in a big pot. And in particular, it borrows it from lots of different languages. So the syntax of JavaScript is what we call C-like syntax. It uses squiggly braces. Its semantics are based on languages called Self and Scheme. So they're actually got functional semantics. It takes all the reserved words, so the words you're not allowed to use for anything other than control. It takes all of those from C and Java. It doesn't use them all, but they're all reserved. Takes an object model that's really hacked together. It consists of things from the basic of a C struct, which is just a way of describing how you lay out memory, through to things like Smalltalk. Smalltalk is a very old language that is in some ways related to Objective-C. It took so this language called Self, this idea of prototypes, we can talk more about it later. So it took the idea of the prototypes themselves in the project model, and it took paradigms from functional languages like this, and Scheme, and threw those in as well. And then of course it had to work with the browser. You had to be able to script bits of the web page that you were, that the code was running within. So in order to do that, it basically stole the event model from a product called Hypercard. And Hypercard was an Apple product that was probably made in about 83, 84. And it had this idea of stacks of cards, so virtual cards. And you could script within a card, so you can have buttons on the card that if you press the button, a bit of code would run. And you could do things across cards, so you could move between them. And you could script all of this using a language called HyperTalk, which still doesn't very much like JavaScript at all, but the event model is very, very similar. So the JavaScript language within the web browser was released as part of the Netscape 2 betas. So still in 95, later in 1995. It worked. It was full of bugs. It had lots and lots of problems, but fundamentally it worked. It had just enough good stuff in it to survive. In terms of what the web developers were using it for, well, mostly annoying things. Scrolling messages in the status bar, flashing bits of text, things that made web pages incredibly distracting. But some people found it popular. In the late 90s, the language was improved further, and a standardization process began under a body called ECMA. So if you ever see ECMA script, ECMA script, that's actually the standard of JavaScript. In 2004, 2005, JavaScript was literally the language that powered the Web 2.0 revolution. This was the advent of the read-write web. So web applications that weren't just web pages that just showed you information, but they were much more than that. Web applications that took information from you that were interactive. JavaScript was the language that powered that and made that happen. Today, JavaScript is found pretty much everywhere. Most web pages, rich client-side applications. It's used in things like in technologies like AJAX. So ways that browsers can communicate with servers behind the scenes in order to transfer information. JavaScript is not only found in the web browser these days, it's finding its way onto the server, and that's what Node.js is all about. Node.js is all about server-side JavaScript. We're going to learn about that later. Even making its way into things like the television. I'll show you an example in a minute. So that's kind of history. That's kind of how we got here. What exactly is JavaScript then? So JavaScript is a language for scripting a runtime environment. What that runtime environment is not specified. It could be Node.js running on the server. It could be a runtime environment running on the TV. It could be the runtime environment of the web browser. Doesn't matter. All of those things are valid runtime environments. The language itself doesn't provide any form of input and output. Okay, so the language specification doesn't provide any I/O. That's all provided by the runtime environment. There's nothing in the language to do with hardware access, on hardware interfaces. There's nothing to do with drawing on the screen, for example. Not part of the language. All of that functionality is provided by whatever runtime environment the JavaScript code is running in. So diagrammatically, it looks a bit like this. You have your JavaScript code that you write, perhaps, and that's running in a JavaScript environment. That JavaScript environment is running within an operating system, and that operating system is running on some hardware. There are multiple layers of abstraction. So what are the common environments? We mentioned a few already, but by far the most common is web browser. That's the one where it started, and it's the one where it's still most commonly used today. What about other environments though? Well, television, I've already mentioned. So lots of smart TVs, even going back 10 years, smart TVs had JavaScript interpreted in them in order to run little JavaScript widgets. Yeah.
Are they all based on Node anyway? Those like desktop things, TV?
No. So I mean, these predate Node by years.
Right.
By many years. Node is very much a recent thing in terms of this history. There were smart TVs probably around 2002. I mean, off the top of my head, I can't remember when Node came out, but it was 2008 probably, around that time. So quite a long period of time. These widgets not only running on TV, running on your desktop. This started with an application called Confabulator. I think it's still around actually. So basically it was a widget environment where you run JavaScript widgets. So Apple kind of got in trouble a little bit for gratuitously copying it with Dashboard. And I think ever since Windows 7 as well, Windows 7 has JavaScript widgets built into it. But you can see here, each of these little things is basically a standalone application written in JavaScript and HTML. I've got a clock, translator, weather forecast, and a thing telling you that I don't have any delivery. So all of these things basically use JavaScript. Here's an interesting one. Java. Java is a runtime environment for JavaScript. In fact, JavaScript is the default scripting language for the Java language. How many people knew that? Anyone? Okay, has anyone used it? Okay. Okay. Yeah. So if you want to try this, take a look at that Java Exports script package. In the recent, I think in Java 8, the most recent version of Java, that's been public release. There's a new implementation of the JavaScript engine called Nashorn. The old one called Rhino. But these are, these are basically Java code, bits of Java code that run JavaScript within a JVM. So Node.js, we mentioned a few times already, but Node.js is pretty much nowadays the de facto for server-side scripting with JavaScript. It's a way that lets you build server applications from the ground up in JavaScript. What about the operating system level? Well, irrespective of whether you've got a Mac or a PC, you've got a JavaScript interpreter at your fingertips if you open a terminal. So on the Mac, there's a built-in one called JSC. That's a JavaScript core, and that's the same JavaScript engine that runs in Safari, the web browser. But there are equivalents in Windows and the DOS command prompt. And these are ways of essentially doing shell scripting. So you can use these as ways of writing shell scripts in JavaScript that do things in your operating system. Quite a way you want to, that's a different question. But it is possible. Okay, so what can you do with it? What can you do with JavaScript? What kinds of applications do you do? Has a really, really wide range. So pretty much anything from, I guess, what it was built for in the first place. So things like HTML form validation, so checking the form is correct before you send it to the server, which does have disadvantages because the user can turn off JavaScript and potentially get around that, so you still have to check on the server as well. But from that, all the way things like games, 3D animation. And you've got a screenshot there of the original Doom running in a web browser that's been ported to JavaScript. And from that, well, you can go further. You can go all the way to implementations of things like emulators in JavaScript that run within a web browser. And I want to show you some of these. Let's start with emulators. So I just run this. Hopefully the network connection will hold out. Yes, but okay, there we go. And that's Windows 95 running in my web browser with a full stack emulation of the x86 CPU and all of that associated hardware. And surprisingly, or not, because the mouse is you get an idea of the kind of speed of this. Windows 98. The speed of this. That's a pretty extreme example of one of the things you could do with JavaScript. You can do things like animations. So this is JavaScript using a thing called Canvas, which is built into all web browsers these days. And Canvas is a thing that lets you draw. So using JavaScript, you can draw on the canvas. In this case, this is a procedurally generated animation of a mine cart going through a mine. It's pretty neat. Interestingly, this was written in part of a competition called JS1K. And let me just show you. The JS1K is interesting. It's about what kinds of applications you can build in JavaScript in less than 1,000 characters. Okay, so really, really few lines of code. Or probably no lines of code, because a few lines that are going to count towards your character limit. But that's kind of a really, really extreme example of some very tight code to do something quite cool. This is quite interesting. So this is a Java virtual machine written in JavaScript. Okay, so you can run Java programs in your web browser, literally in your web browser, with a JavaScript virtual machine. You can do crazy things like, if I load Nashorn, I don't know how long it'll take to load, but I can run JavaScript code in like JVM, which is written in JavaScript in a web browser. A bit meta. So in order to just demonstrate this, if I say print hello, well, and we get to run, you can see it's a little bit slow, but it doesn't respond to hello world. So that's JavaScript code running in Java, running in JavaScript. Doesn't really have any practical uses for me. It's pretty fun. Need it to load. So this really, in terms of graphics, shows what's possible. Wait for it to load. Whilst it loads, so this is Quake, the original Quake 3, the JavaScript port of Quake. And it literally is as it was when it was first released. I mean, the performance is very much similar. Smooth, sounds work. Okay, all written in JavaScript.
你说他们他们做的项目 没这么牛吧？
Some people did something really, really crazy. They took WebKit. So does anyone know what WebKit is? WebKit is the rendering engine that's used by Chrome and Safari. Okay, so it's a rendering engine for rendering HTML. These crazy people took the WebKit source, which is written in C++, transformed it to JavaScript, and made a version of WebKit that runs in JavaScript inside your browser. And actually, this picture here is generated essentially not by the browser itself, but by JavaScript running in the browser. This is interesting because it does have some practical applications. One of the big problems with web browsers is incompatibility between different manufacturers. But now your web browser is written in JavaScript, and it just runs in a different web browser. So you can make things so they render the same everywhere. With the caveat that it's a little bit slow at the moment, but things are getting better. So this is really a nice one. One more. So a lot of you know that I teach computer vision. One of the things that I do as part of an outreach activity is teach computer vision to sixth formers. And sixth formers, they don't typically know or have programming skills as good as our third years. So we needed a way to be able to teach computer vision to them, or show them some of the basics without any, without really much programming experience. So we came up with this. And this is a thing that runs in a web browser and lets you do computer vision-like things. So you've got a live webcam in a web browser. You've got two images, because one's the input image and one's the transformed image. At the moment, the code here, that code is basically copying every single pixel from the input to the output. It's not doing anything exciting at all. But what I can do is modify the code and run it. And for example, I can invert the image in real time. And I can do other things. I could do something like this, but do edge protection in an image. Again, in real time in JavaScript, running within a browser, making use of the hardware because of the models in web browsers that let you actually access things like webcam. Okay. Little caveat. Some of those things are really, really cool. Were they all written in JavaScript? Change. Give it a yes. No one. Give it a no. I guess everybody else. So there's a little bit of a catch. A lot of those things, especially the emulators, were essentially written by transforming the code from the original language, C++, C and C++ typically, to JavaScript automatically using tools like Emscripten, which is basically a cross-compiler. Cross-compile your original source code to JavaScript. And these tools have become really, really powerful. Especially because a lot of people don't like JavaScript as a language. It has lots of flaws. And these tools let you write your code in your favorite language and transform it automatically. What they don't do, though, is produce readable code. So anything that's produced with these tools in JavaScript that's produced with these tools is really a mess. Okay. So yes, the answer was yes and no. That's given you a bit of a taste of where JavaScript came from. Now, I've already alluded that there are a lot of problems, and that's fundamentally what we're going to talk about for the next 4 lectures. We're going into some of the details and look at some of the problematic bits. Because we've still got some time left in this lecture, I want to show you a video. It'll be a good way of wrapping up and leading into the next lecture. So, sit back and enjoy one. Alright, good. You guys know what WAT means? WAT? Exactly. Let's talk about Ruby. In Ruby, if you reference an undefined variable, of course it name errors, as you would expect. And if you try to assign B to A with them undefined, of course it name errors, as you would expect. And what happens if you try to assign A to A with A undefined? Correct. Nil. WAT. Let's talk about Ruby. Ruby, unlike some other dynamic languages, does not have bare words, so you cannot just type words in and have strings come out, unless you define a particular method missing that does the right thing. And then if you type bare words, suddenly Ruby supports bare words. And in fact, it will even support bare words with bangs in them. And this is not deserving of WAP. This is actually a result of how awesome Ruby is. But if you ever actually do this, then WAP. Let's talk about JavaScript. Does anyone know in JavaScript what array plus array is? Well, let me ask you this first. What should array plus array be? Empty array, I would also accept type error. That is not what array plus array is. Wrong. Wrong. Array plus array is empty string. Obviously, I think that's obvious to everyone. Now, what would array plus object be? This should obviously be type error because those are completely disparate types. Does anyone know what this is? No. Close. No. Far away. It's object. Right. Nicely done. Now, of course, because this is plus, so you can flip the operand and same thing comes out. So if we do, what? No, that's just an object. If you do object plus array, you should get exactly the same thing, which, as you can see, you do. And finally, the only one of these that's actually true is, because, you add array to the empty string, that doesn't make sense. But an object plus an object is actually not a number, technically. So this one's actually right. And exactly, right? Like, what is even going on in this lab? I don't even understand what person with a brain in their head would think that any of this is a good idea. Okay. Enough making fun of languages that suck. Let's talk about JavaScript. If I say array.new 16, or just array 16, I get an array of 16 things, which it represents as 16 commas, which is obvious. And if I then join those with a string, then I get the string 16 times. This is actually the only line in this entire presentation that's reasonable. Now, if I take that string and then add a 1 to it, it interprets the 1 as, or
cast the 1 to a string, and then we get WAP1 a bunch of times, fine. Does anyone know what will happen if I subtract 1 from the string? I'm assuming no one does. I'll give you a hint. Does this help? Does anyone know? Wet dad. That's all I got. Thank you.
Okay, so that's given you a little bit of a taste of what's to come with JavaScript. I should point out that when that was, so for those of you with Mac in front of you, if you try doing that now, the latest version of JavaScript 4, you get completely different results. Why? Well, a few things have happened. That was made around the time of ECMAScript version 4. ECMAScript version 5 fixed a few things, not all of them, so some of those behave in a completely different way. There's still many cases where there's no guarantee that something running in JavaScript 4 would work the same as in, for example, V8, which runs in Chrome. There's still lots of cases where the JavaScript language is interpreted differently. Don't worry, it's all going to be fixed in ECMAScript 6, but that's not supported by any browser properly, with the exception of Chrome, does most of it. But the others, no, not yet. It's coming in the future. I don't think it's going to fix all the problems either, because there are still some really crazy things in the language that we'll cover later that are actually in the core of the specification. Okay, so I think at this point, it's early, but we will end now. I'm obviously happy to take any questions if anybody's got any. I'll hang around the front for a bit as well. If you haven't formed your groups for your project, do so. What's happening? We're going to meet again in about an hour, 20 minutes or so.
我没意见。我也下午2个打电话。对。但他都说了，你不叫他一起不太好。他是跟你说了吧？叫5个了。